Hello everyone. Today we will cover the tutorial of Python for our course Natural Language Processing. We'll first see the installation steps where we set up Python with the Anaconda environment. Second, we tell how the different parts of programming basics like operators, flow control, and specifics to Python like lists and dictionaries. Finally, we go on to how to import and work with packages, particularly Pandas and NLTK, which will be very useful for our course. One key point of difference that I would like to highlight is that Python utilizes this Python interpreter, which executes each statement line by line, whereas this is different from the compiler based languages like C and C++, where the entire program is executed as a whole, which means that entire source code is converted first to an object code, and that as a whole is then executed. Okay, so let's dive in how to set up Python. So let's go to, we have to download the Anaconda individual edition. So let's visit their website. From their website, you can see there is this download instruction based on your operating system. You can either download for Windows, Linux, or the Mac-based systems. Once you are able to download, the next set of instructions like how you should then move forward is also available here, which you can go through it. Okay, so any doubts regarding this, or if you have any problems setting this up, there are other tutorials you can go through, and if still you are not able to complete it, you can put up the doubt in our Thursday's tutorial and I will try to help you set it up. Okay, so once it is set it up, it will look something like this. So here you can see that the Conda is set up with the base environment. Okay, so what we will do is next we will try to set up this virtual environment. So what is virtual environment? It is that you have a system set of packages, or you can think like in Windows or in your Unix based systems, Python is also accessible, and suppose you somehow update your system, the Python versions of the packages can also get updated. So the codes that you write using the current versions of Python and its dependencies may also fail to work in that cases. So for that, what we do, we create a isolated environment known as the virtual environment, where the packages as well as their dependencies are maintained. So irrespective of your system-wide update, you will still be able to run your old set of codes. So how to create that? So in Conda, you can copy paste this line. See, so I've already created an NLP 2021 environment. So let's keep it a different name. Let's give it test 1. Okay, let's see what it does. So make sure you are connected to an internet connection so that the packages get downloaded. Okay, so now this says that it is the creation of the virtual environment is now successful. Also, they give you pointers like how to activate the environment. So the will be that every time you start working on this particular course related assignments, you go to this first terminal line and then you always go inside your environment. That is, you always activate your virtual environment by this command NLP. So our name is NLP 2021 test 1, and we press activate. So now you can see in the start of it, the name of the virtual environment is mentioned. You can also deactivate it by using the conda deactivate command. Okay, great. So once this is established, we can also install these packages. But since Anaconda comes with this pre-installed set of packages. You can run it, but most of them will already be there, or all of them will be there. But still, so for future packages which you do not find in this setup, you can run this program, run this line. Let's see. Okay, so it says that it needs to install a group of packages. Okay, so this is under. So yes. This may take some time, so let's wait. So let us continue. I think it will be done. Time. Okay. So so now we start our basics of programming and how is it for Python. So first is printing any string or printing any statement. Starts with hello world. So you simply write print within the single quotes, or it can be also double quotes. You mention the string and it is a single statement. You can also write multi-line statements. For that, you have to enclose it within 3 quotes in that way, end and way. So here we are writing hello world, where hello and world are on different lines. So once the printing is done, we try to see different operators or mathematical operators, like you can see here, the binary operators like plus or multiplication, like 1 plus 12, 13, 6, 5 into 6, 13. Next, we can assign variables, like assign values to particular variables by using the assignment operator, that is the single equal to symbol. So num1 will now have the value 13. So one important point to note here, that we are not explicitly mentioning what will be the variable type. So Python automatically detects that, which we'll see later on. Like as you can see here, like if I just do the type of num1, it will give that it is int. Okay. Second is that we have also Boolean operators like less than, greater than, less than equal to, greater than equal to, which will output either true or false. Also, when we use double equals to, it again becomes a Boolean operator, that is equality, and it will output whether num1 is equal to 13 or not, which in this case is true. That's why it is returned true. Okay. So once we are done with the operators, we will go about with the conditional statements. Like the most popular that you will come across is this if else, only if, or if else, if and else. So suppose let me let me change it to num1 is 9, suppose. So now what it will print, since num1 is 9, so it will go to the first condition and it will check whether it satisfies it or not. So as we can see that it satisfies it, so it will go inside this scope. So in C or other programming languages, you may have seen the scope to be defined through braces or like double brackets, but here the scope of the particular command or this particular statement is determined by the indentation, which currently here is a tab. So this entire 3 lines is within the scope of num1, meaning If this particular condition is satisfied, all these three lines will be executed. So since it is satisfied, num1 is 9, so it is printing the three lines. 9 is less than 10, condition 1 line 1, condition 1 line 1. Suppose let's us try different things. Suppose I change num1 to 12, and if we again run it, we see that it goes to the second condition, that because the first condition is false, it goes to the second condition and sees that 12 is more than 10 but less than 15. And if I make it more than 15, say 20, so here you can see it first checks the first condition, then the second condition, and then the third condition. If any one of them is executed, is satisfied, it does not go to the next. Okay. So this was if. So there can be variations of this. It can be only if and without any elif or else. It can be if and else, there is no elif, which we can see or you can play around with. Okay. Next is flow control. Like if we go into iterations or loops, for like there are many ways to that. We will explore the most popular one, that is the for loop. So here for index in range 10, we print all index. So this range is a new thing. So in such cases, when you will encounter some say new functions, what you can do is that you can just search for it. That is like say range function in Python, suppose, and let's see what it shows. So, and you see open the first one. So here it will tell what is its range and what is its definition. So what it says, that this range function, it returns a sequence of integers starting from 0 by default and increments by 1 by default and stops before the specified number. So this range is a function which can take like 3 arguments as input, but as you can see here, only one of the argument is required, means that you have to provide, but the other 2 arguments are optional. So these optional arguments generally are associated with a default value, meaning like if you do not mention anything, it will automatically think that okay, the default like here is 1, whereas here the start's default is 0. So in our case, when I write range is equals range 10, it assumes that the start is 0, the stop is required, so stop is equals to 10, and step is optional, that step is 1. So it automatically thinks that, so let me just comment it out, like it automatically thinks that the start, because the start's default value is 0, the steps default value is 1. So it will start from 0, increment by 1 and go up till 10, not including it. So it starts from 0, goes up to 10 without including it. Similarly, if we now give all the 3 arguments, then the default values are overwritten. So now here the start is at 10, stop is at 0, and the increment is -1, meaning it's actually decreasing by 1. So it will start from 10, go up till 0, but not include 0. So as you can see, it is also printed the same. Next is that we have learned previously about these conditional statements. So if we put it in combination with this, how it turns out, let us see. So if we write the same function that goes from 0 to 9, and then we only want to print the odd numbers. So here what we do, we put a conditional statement where we say that if the modulus is 2 is equals to 0, because means that if index is divided by 2 and the remainder is 0, then we print it. So it will print all the even numbers as it has rightly done so. Also, there are other ways of flow control, like iteration is one such way. For loop, there are other while loops. Other statements are like continue and break. So what does continue do is that whenever you encounter a statement called continue, it will not execute any following parts of the code that is within the same scope. So by scope, I had told you before, like this is like all the parts of the code within this indented portion. So the scope for or this statement is the entire portion, right? So whenever we encounter continue, it will no longer execute the remaining portion of the code belonging to the same scope and will go back to the iterative statement. And break, what will break do? Once you encounter break, it will exit the nearest scope. So the nearest scope is the for loop. So once it encounters break, it will exit the for loop. So that's why you can see that it starts from 0, it goes through 1, it goes through 2, it goes through 3, it goes through, but when it goes to 4, it goes back. So since 0, 1, 2, 3 passes and 0 and 2 are even, so 0 and 2 are printed as it rightly so. But when 4 passes, it encounters, it satisfies the first condition, it goes to continue and no longer passes. So this part is no longer accessed and it goes to index and it is incremented to 5. So even if 4 is even, it is not printed. So as you can see, there is no 4 here. Similarly, it goes to 5, then goes to 6, then goes to 7. Once it goes to 7, it breaks the for loop and no longer, and it gets out of the for loop. So it no longer executes 8, 9. Okay. So till this portion, we have covered the operators, like assignment operators, how to set up Python. Next, how to use conditional statement, flow control, and flow control along with conditional statements, right? Next, we go on to some few specific properties of Python, like which are like list and dictionaries. So one primary difference, or like one primary characteristic of list you can think is that it may contain duplicate values. So there is another type of element like list is known as set, which will not contain will no duplicate elements, which will not contain any duplicate elements. Okay, great. Let me just write it down. Okay, so like the list can be directly initialized, like this is a list of length 10 which has numbers from 1 to 10. It can also be written in this form where you mention the element and the number of times you want it to appear, and like you want the element 1 to appear 5 times and the element 10 to appear again 5 times. So here the plus, we have encountered this plus operator before. It was an addition operation before when the two operands were just integers, but here since the operands are these the list, here it behaves as a concatenation operator, meaning that it will take the first list which contains of 5 ones and will append it to the list that contains 5 tens, which we can see. So in that is, this will be list 2. So as you can see, list 2, the first 5 elements are 1 and the last 5 elements are 10. And the same we do for list 1 and list 2. We can again append, and you can see list 1 first 10 are 1 to 10 followed by list 2. Okay. Now each of the, now this list are different data structures which can have is associated functions, like it has a len function which will tell the number of elements that is present in that list. For example, in list 3 it is 20. Okay, and we can always, given any variable, you can like see what type it, what is the variable type. It's for example list. So this reiterates the previous point that I was saying, that Python automatically assigns these, so we do not need to explicitly assign this type assignment, Python automatically does it. So they automatically decide that this list 3 is of type list. Great. Next point is that how do I access the elements present in the list? So you can access it using their index. So one point, key point is here that the index starts from 0. So here if I see that the index is 10, so this means that I want to access the 11th element in the list. Okay, so what is the 11th element in list 3? The first, this is the first 10, and the 11th is 1. So the output is 1. Okay, so I hope the list part is now clear. The second data structure, as we mentioned, is the dictionary. So dictionary has this characteristic that it will have a key, and this key can be this value, and corresponding to this key there has to be a value, right? So you can think like in a dictionary you have the words which you want the meaning of. So the word here is the key, and corresponding to each word you can have various sorts of information, like it can be like the synonyms present, the different contextual meaning of those words. So instead of apple, which is a string, it can also be a list, right? It can be int also, the value type, right? So this is a dictionary. To access the different elements of the dictionary, you have to access it using its key. So dict A or dict C, when you call it, you will get the value corresponding to that key value in the dictionary. So like I told in list, there is len or some other function. So if you go through the documentation, as I showed one in case of range, you can similarly search and go through the documentation, and you will find more such functions that are predefined. These are predefined functions, so you do not have to rewrite the code there, right? So dict1.keys will output you the list of keys here, like A, B, C in our case. So this is a traversal function, like how to extract the all possible values regarding your keys. So what we do here is that for key in dict1.keys, so dict1.keys returns the list of key values, and there we iterate over each such value, and we say that okay, first it takes A, so it goes to dict1 A, instead of C it is like A here, and it outputs apple, right? Then it will go dict within brackets B, within quotes B, and will output ball, right? And continues. So in this section, we covered the lists and how the dictionaries work and how they can be accessed. Now we come to more specific components for the natural language processing course, which you find important. First will be reading and writing, or particularly reading different file formats. So most popular way, there can be other file formats, but we will deal with the most popular ones. It can be either comma separated value CSV files, tab separated value TSV, and also text, simple text file. So we start with the simple text file. How it can be read, we can use their inbuilt file operators, open the path to the file. So this path, as you can see, is a relative path. So what is a relative path? It is so wherever you have kept this particular code of the program, yeah, so with respect to that, where is this data placed, right? So if I see this directory structure, let's see the directory structure. So this is the particular, this is our current IPython notebook. So with respect to this IPython notebook, where is the data present? So it is present in the data folder, then on the data folder under introduction. So the relative path is data/introduction. Okay, so this is a relative path. Let me just write it. Okay, so this may be little new, looking little different to you. So the idea here is that whenever you open a file, you have to also close it. So an alternative to this was I would just do a fread, as like, because we are putting this like within quotes R means that we want to open this file, but for the purpose to only read. If I want to open this file for the purpose to write, I would write it as W here, right? So this is only for reading the particular file. So the idea is that whenever you open a file, we also have to close it. So the alternative way was to do f open and followed by f close. But this is a way around that, where we say that within the scope of this line, means the scope is again established by this indentation, that is a tab in Python, like 4 spaces. It is established within this scope. It is open. After whenever we exit this scope, it is automatically closed in that way. So you can see that we can read this file. So if I open the file, maybe it will be more clear. So this is a text file which has this line, and so when we read it, as you can see that it is also giving original text f.read hello world. On the next line, you are now reading the second line of the file. Great. Second, to read the comma separated values and the tab separated values, we will show you how using a package called pandas. Like, so what is a package? You can think as package to be a set of uh, pre-written codes which you can access based on, if you know what arguments is take, the type of values it expects in the argument, and the what it returns, right? For example, we will go with respect to pandas. So suppose you know that pandas is a package that is generally used to read CSV files. Now I will show you how can you read the documentation and come up with the correct line of code. So this will help you in future cases when you need to use a certain package for a certain task. So for example, like if I know that pandas is used to read the CSV file, I can just do a Google search using it, like pandas read CSV. Suppose I want to write documentation because I'm interested in that. Let's see. So the first result is of a documentation. Let's see what it says. So it says some important parts. First, it says that pandas, there is a function known as read CSV. What it takes as input? It takes as input the file path, the separator, and lots of many things. Now you have to see, first you have to check which of these arguments are optional and which of them are compulsory. Like here you can see the file path is the only required or mandatory part of the argument. The remaining are optional. Whenever an argument is optional, it will have a default value associated with it. So let's see how to read it. So like file path you have to mention, which is a string, that is the data path that you are there. Like you see sep is optional. That's why you may or may not explicitly give that value. So it will always have a default value associated with it. So here you can see the default is comma. So if you do not mention anything for sep, it will assume that the sep is a comma. That is a CSV file, a comma separated value. Similarly, delimiter, that we always have a default value associated. Header default value is always there. Okay. Next important thing to look at will be the return type. Like what is it returning? So as you can see here, it mentions that the return type is a data frame. So once we write this line that, so because this is like the data that we'll read our data from this UCI ML repository, which is like a real life data, so it may have some nuances. So you have to download this data from this link. Once you download it, it will be in a zipped format. You should unzip it, and then you will have this folder. So folder will have a train file and a test file. Okay, so here what we do is that we are reading the train file, right? So train.tsv. So you can see the ending is tsv, means it is a tab separated value. So what we do here is that we take that input like train data, equality operator or assignment operator, and say that we are reading the CSV file. This is the file path, and instead of the default comma separated value, it is a tab separate. So we have to explicitly mention it. So now we knew that the return type is a data frame. So train data is a pandas data frame. So what is a data frame? You can simply think it to be a 2D matrix where you have where each column has some name and each row can have some name, right? So if you just read the top, so as I saw, like in list, they are associated with certain functions. Like here, you can also see that train data or a pandas data frame can have this function like dot head, which outputs the top 5 rows of the data frame. So as you can see, the columns each have a name, and the rows have been automatically have some names given like 0, 1, 2, 3, 4. Okay. Now, like we have accessed the different elements of a list, traverse the elements of a dictionary, we do a similar thing with the data frame. So here, if I want to uh, extract or print the element at the ith row and the jth column, for example, I want to extract when I is 0 and j is 0. So it will extract the element at row index 0, means the first row and the first column, that is 2202, followed by first row second column, that is NLTK. That is what is printed. Other functions can be like, if I want to print all the names of the columns, this you can. Next, if you want to traverse the column, here I show that you want to traverse one particular column. So for example, here the column is, it is column index 1, meaning it is a second column. So if we go here, meaning we want to traverse all the rows of the second column. We want to traverse all the rows of the second column. So for that, what we do, we start from row index, range, train data, shape 0. So this shape, like you can think length of list, the shape will give you the number of rows, comma, the number of columns of the pandas data frame. So at position 0, it returns the number of rows. So for row index in range, number of rows starting from 0, incrementing by 1, it will iterate and will output. So you can see it starts with at row 0, like you can think it this way, like first row, second column, second row, second column, third row, second column. In that way, it outputs for all the rows present in the data. So till now, we have seen how to use pandas to read the TSB file. And in case of CSV file, we do not need to mention the SEP because we know by default, it assumes it to be a comma. Correct? Okay. So let's move on. So the final package we will discuss today is this NLTK package. So this is specifically designed for the for natural language text processing. Okay. So here you can import NLTK like we did import pandas, and we try to download this WordNet. So here there is a difference. So NLTK or these packages contain mainly these functions associated with it. But NLTK, you can also, they provide an interface by which we can download natural language processing related resources. Like it can be like some well-known corpora, which is kind of, you can think like a collection of text. It can consider access to data sets. It can give you access to certain benchmark, I will say, benchmark resources like the WordNet in this example. Like it contains words, their synonyms, and how they are linked with different meanings of other words, right? So it contains all this variety of resources which you can separately download. So for example, in the future, for this lemmatization task, which we'll later discuss, like this WordNet lemmatizer, which depends on WordNet to lemmatize, we need to download WordNet. NLTK.download WordNet. Similarly, for other parts, we'll also download, which I will show you in the future. There, while trying to download it, it showed one error, which I used Stack Overflow to remove it. So Stack Overflow is a very famous website which you can use to debug. So for example, if you just write Stack Overflow followed by, suppose you write say NLTK download error, suppose. So it can have multiple errors. Suppose if I take the first error, so you can see that while trying to do NLTK download, it was showing true, but when he was trying to do NLTK down all, there was some error. This error loading all URL open. Then he goes on to explain how he came across this problem, and later some people will try to solve it, and generally it is generally gets fixed. So you can look for the green tick or the one which has the most upvotes, and you can try those solutions. Like I tried their solution of like create unverified this part, as you can see here, and it worked from. Okay, so you can check once when there is a green tick in the Stack Overflow, and second if it has the highest upvotes. Okay, let's move on. So now we will show that how to tokenize words, tokenize sentences, how to remove stop words from sentences, how to use one type of stemming algorithm called Porter stemmer, one type of lemmatization algorithm called wordnet lemmatizer using NLTK. Okay, so for that we will try to extract one paragraph from our training file, that is the first row 7th column. So let's see what is the first row 7th column. It will be benefits review. So it is slowed the progression of left ventricular death, something with this. Let us see. So this is the entire paragraph: slowed the progression of left ventricular dysfunction into overt heart failure. So as you can see, since it is a real life text, it will contain misspellings like failure does not have a he, management also missing a e. There are not well delimiters that these which marking the end of the sentence. So these will be present in your real life data, and you have to go through different text processing steps as was explained in the slides to remove them. Okay, so next, when we try to first we try with tokenizing the paragraph into words. So when I tried to do it using word tokenize, so it showed an error that this to do this word tokenize, it depends on this punkt resource of NLTK, and it was missing. So for that I downloaded that punkt package and successfully completed, and now it works. So this is the text after doing the word tokenize. As you can see that each tokens like slowed is one token, the is one token, progression is one token, off is one token. So this is the result of word tokenize. Second, if you want to tokenize these sentences, you can again pass it through the same command of send tokenize, and but here you can see the entire paragraph is considered as one statement. Why is this? Because send tokenize depend on certain predefined delimiters, which in our case is missing. Like as you can see that it is just, so instead of a full stop or end of sentence or a semicolon, it is mentioned like a new line character is mentioned. So what we can do is that if we see that this is are artifacts of your data set, you can replace it by the appropriate delimiter you should think. So for example, in this case, I replaced it with the full stop. And now the new paragraph looks like this. Like instead of that /r/r/n, it has a full stop. Now, when we do the send tokenize, it correctly breaks down the sentence into 3 sentences. Like after heart failure, it is full stop, alone, full stop, management of heart failure. Okay. So these are some text processing steps you can do using sentence tokenization and word tokenization. And now we come to the last part of our of today's tutorial is of removing stop words, porter stemming, and lemmatization. So for removing the stop words, there is a separate resource in NLTK which you have to download. Otherwise, whenever you call this and then this part, it will show an error that stop words module is missing. Okay. So from NLTK corpus, I import stop words. I print the list of stop words. What is set? Set is done to ensure that the stop words, there are no duplicate stop words in the list. As you can see, the stop words are like some prepositions like in, off, on. There are some contractions like wouldn't, would, something like shouldn't, don't without a T, in that way. That all, right? Next, we will try to see that, okay, given a document, how can I remove those words which belong to stop words? That is one way of cleaning the text, because as you have read in the lectures, these stop words are present in a very high frequency, and that somehow like affects our models to understand what are the important words or the important content words. Okay, so we will now show you a shortened version. So this is known as a list comprehension. Like instead of writing a full what I will say, instead of writing a for loop, if loop, you can merge it into one thing known as the list comprehension. So let us analyze it. So how we can rewrite this? We can rewrite this in this manner. Let me make a file here. So what first is that I want to read each token in my paragraph, right? So what I do is that I do word tokenize. So word tokenize, it will output what, as we have seen before, each token separate, like slowed separately, these separately. So for word, meaning it will start with this word, like it will take for like slowed, right? Then it will check if the word is present in the stop word list or not. So what we are trying to do, we want to remove words that are present in the stop words and only retain words that are non-stop words. So what I will do that, okay, if it is a word, right, let's put it inside the scope. If word not in stop words, okay. If word not in stop words, right? If it is not in stop words, then you add it to this clean text thing, right? Then you add it to this clean text. Suppose this is some kind of list, so you add it to this list. Fx append word, and you have to of course initialize this clean text as a list, and you're just keeping on appending those words which are not stop words. And lastly, so your output, this clean text will be a list. Lastly, you are saying that each element of your list, I want to merge them into a single string where each element will be now be separated by a space token. So you can think that this entire list, you can now find it as a one single string. So as you can see in the example, before it was this slowed the progression of left ventricular dysfunction. Now after this stop word removal, the is removed, off is removed, into is removed, and then it is made into one single string, right, after removal of them. So all this combination plus this extra step of the, it is done using this single line. Okay, great. Last second is that this stemming. So for stemming, what we can do is that I think I have written that okay, from NLTK stem we use this one of the stemming algorithm that was covered called Porter stemmer. And how to do this Porter stemmer is like let me show you one this part, then for the wordnet lemmatizer you can do on your own. So suppose you know that there is NLTK, and we have the Porter stemmer algorithm using which you can do this stemming. But what is the documentation you do not know, or how to go about it you do not know. How do you get from there to the code part? So you just search using NLTK and Porter stem, and you just go through parts that where it is somehow explained. Suppose this part. Okay, so what it is showing is that different places where people have used Porter stem. So first thing it is doing is that it is creating an object out of it, like Porter stemmer. And then what it is doing, let us see. Okay, Porter stemmer PS, and then it is using it to stem the words. Okay, so we can do the same. So what we'll do is that we are also creating this object Porter stemmer, and now we take the same format as before. Now what we are saying that, okay, we are going through each word like we are doing before, but now we are not interested in whether it is a stop word or not. We are more interested that for each word we will stem. So we pass each word to stemmer dot stem, and we pass the each word. So each word is now then concatenated. The stemmed version of the word is now concatenated in the text. And finally, we say that each element of this list will be separated by a space and converted into a string. So as you can see, before it was slowed the progression of left ventricular overt heart failure. After that, slowed is converted to slow. The remains the same. Progression is converted to progress. Off remains same. Left ventricular remains same. Dysfunction is converted to defunct, and so on and so forth. So the part that I will leave is this lemmatization part, which you can try and let me know later. Like if you have any doubts to get, if you are unable to do that, I can help you. So you can use it, NLTK stem wordnet lemmatizer, and search similarly that as I have showed you for the Porter stemmer, see how to write it and output this file that, okay, before stemming it was this, after stemming it is this. So this is for this, and in your case it would be before lemmatization it was this, after lemmatization it is this. And let me know if you just play around with it in that. Okay, so this is all for today, and I hope you enjoyed the lecture, and if you have any more questions we can discuss it in the Thursday tutorial. Thank you.